Hello and welcome to this lecture on integral calculus. In this video, we are going to see about the problems related to triple integral, and we are going to solve uh, the volume of ellipsoid using a triple integral. Let's start. So, finding the volume of ellipsoid by using the triple integral. So, simply I'm giving the idea as same as the sphere. What we do there, we split a sphere into 8 equal octants. And if I find the volume of a first octant, if and I multiply with 8, then I will get the volume of total ellipsoid or sphere. The same thing. So we apply the same process, and here what we will do to evaluate this, it will be 8 into triple integral over the region, and here it will be of dx dy dx, or else dx dy dz, according to which you have to find the regions for the limits of x and y. Okay, first here we used to solve this problem by the region of dz dy dx. Okay, so first we will find the limits of z. How do we find this? Simply from this equation, if I equate this equation z square by c square equal to 1 minus x square by a square minus y square by b square, then it becomes z equal to c into square root of 1 minus x square by a square minus y square by b square. So as same as that, in origin all the variables x y z starts from the origin, so the lower limit will be always 0. So here we get the upper limit of z, then I go for the value y. So after evaluating the function with respect to z, then we go for the variable y, so there should not be any variable same as the value we have in the function. So here we are going to find the limit of y. So this upper limit or lower limit should not contain the variable y again. So we are making this y to 0. So how it is possible? In this, I may take this again. I am making this equation simply substituting y equal to 0. So the remaining term will be a square x square plus z square by c square. Z term to 0, sorry. I am making that z term to 0. So x square by a square plus y square by b square equal to 1. So how do you find the value of y here? Y will be equal to b into square root of 1 minus x square by a square. Okay, next this will be the upper limit. Next we go for this value, then I will equate the value of x and y and z to 0. So we get the last equation x square by a square equal to 1. So simply x square will be equal to a square, which implies x equal to a. So we get the upper limit of x equal to a. So we find all the limits and we have the integral part. So the next we will do with the process. So before that, here it will be dz dy dx. All the lower limits will be 0. Here this will be 0 into square root of 1 minus x square by a square minus b square, and here it will be b into 1 minus x square by a square, here a. Okay, so now first we will evaluate the inner integral. So integral of dz will be z, and then we have to apply the limits, then c2 square root of 1 minus x square by minus y square by b square. Okay, so then the step, this is the step we have evaluated, and then We will substitute the limits, then we will get this step. After this, how do we solve the remaining? So let me do this. 0 to a, then again the limit 0 to b into square root of 1 minus square by a square. So in order to solve this problem, because we have to evaluate the integral part with respect to y, so I may simplify this term as square root of 1 by b square. I am just multiplying and dividing it. 1 minus x square by a square minus y square into dy dx. Okay. On the next step, I may take the constants outside, so it will be of 8c. So on the previous step, I used to see on the constants outside, now it will be of 8 by b. So that remaining will be 0 to a, then 0 to b into 1 minus x square by a square, and then here I have took the value 1 by b square outside, so it become 1 by b here. So on the remaining we keep inside at 1 minus x square by a square minus y square. Okay, then dy by dy dx. Then again a c 0 to a, then in order to simplify this term, I may do one more step. Just simply 1 minus a square, and I may take this term as square root of b into, I may take this 1 minus x square by a square, the whole square, same as the limit, because we may use a substitution method to simplify this expression. So now we can observe that the upper limit of y is same as this term. So I may consider this term as capital A. For simplification, and on the next step it will become 0 to a, then 0 to capital A, then square root of capital A square minus y square dy dx. Okay, on the next step we have some standard formula that integral of square root of a square minus y square dy will be equal to y by 2 square root of a square minus y square plus a square by 2 sine inverse of y by a plus c. Okay, so this is the formula. This is the formula, so we may use in the previous step. So it becomes 8c by b then here the limit is 0 to a, then I may use this formula here. It become y by 2 square root of a square minus y square plus a square by 2 sine inverse of y by a. Then I have to apply the limit here dx. So on the next step 0 to a, if I apply the upper limit to here simply you just see in the place of y I have to apply the upper limit. A square minus a square becomes 0. Then here sine inverse, the remaining a square by 2 will be there. Sine inverse of a by a na, it become 1. So the upper limit is over. Then go for the lower limit. If I substitute y equal to 0, this whole term becomes 0. Then if I substitute y equal to 0, sine inverse of 0 will be 0. So the lower limit values will be 0 again. So dx. So the remaining term will be 8cb integral 0 to a, and sine inverse of 1 will be pi by 2. So a square pi divided by 4. Okay, into dx. So on the next step it will be 8c. So again I will write the step what we get previously, a square pi divided by 4 dx. What we assume the value a equal to b into square root of 1 minus x square by a square. So where capital A is equal to b into square root of 1 minus x square by a square. Okay, so and then I may substitute the value here 0 to a, 0 to small a, and capital A will be of b, and 1 minus x square by a square the whole square into pi by 4 dx. So again here it is of b square, so I may take the constant outside b square by b, and pi is also a constant, so I may take this all the constants outside, and the remaining it will be of 0 to a. Then square and square root it will get cancelled. The remaining term will be 1 minus x square by a square, x square by a square dx. So here it will be of 2 b c pi, then 0 to a 1 minus x square by a square dx. Then we can split the term. It will be of 0 to a dx minus 0 to a x square. I may keep 1 by a square as a constant, and then okay, on the next step it will be of 2bc 2bc pi, and while evaluating this it will be of a 1 by a square is constant, and previously it will be of square integral of x square. So here it will become x cube by 3 0 to a. Okay, a minus 1 by a square a cube by 3, and here bc pi a minus a by 3. So it gives 2bc pi into 3a minus a by 3. So it will be of 2bc pi into 2a by 3. Finally we get the answer 4abc, 4 pi abc by 3. So this will be the volume volume of ellipsoid equal to 4 by 3 by ABC. That's all.